So the temperature inside of my solar oven that I built is almost 90 degrees already, and we just put it out 5 minutes ago. We're making s'mores. Oh, we hit 90.
It's already up to 90?
Yeah.
Wow, we just put this out.
94, 101.5.
So I wonder what the melting point of chocolate and marshmallow is.
I bet we could find out.
We might have to go look that up. So can you explain how your oven works, Ariana?
So this is my solar oven. So we have black construction paper on the bottom because black absorbs sun best. And then we have our tin foil on the top to have the sun reflecting on, and the plastic wrap to make the greenhouse effect, and this wooden dowel to align the sun with our s'mores.
All right. What's our temperature up to now?
94.4.
All right. Wow. So it was at 80 just a little bit ago. So that temperature's coming up in there really quick. Okay, so what are we observing here, Ariana?
Our chocolate is already starting to melt at 97.7 degrees.
So we can go inside and we can look up the melting point of chocolate. But if you think about the M&M's commercial, M&M's melt in your mouth, not in your hands. And that would mean that chocolate melts at about human body temperature, which is about 98 degrees.
We're at 98.8.
So we're almost right at body temperature, and we have chocolate that's already starting to melt. So now the next question is, what is the melting point of a marshmallow? That's our next question. But it looks like chocolate melts at human body temperature about 98 degrees.
Between 86 and 90.
That's the melting point of what?
Chocolate.
Chocolate?
Between 86 and 90.
Okay. And marshmallow?
Marshmallow was 98.6.
All right. So both of them are going to melt at extremely close to body temperature, and our oven is already at that temperature, so we can go back out and check our s'more maker again. Okay. So we're back again. The temperature is up to
103.6.
103 degrees. The chocolate seems to be melting beneath the marshmallows. Just going to have to be patient.
The marshmallows do look crispy now.
Starting to toast?
Starting to toast a little.
So we are up to 113 degrees on the thermometer. Chocolate's melting pretty good on the left. Not so much on the right. Not sure why. And the marshmallows continue to hold steady. So, what's the temperature at, Ariana?
114, well 115 now.
115 degrees. Looks like we've got some good melting on the chocolate. The marshmallows not so much, but class is almost over, so I think we're going to take them inside and test them. It's time to give for the ultimate test here. Go ahead and crack it open. Are you going to want a topside graham cracker?
Oh yeah.
Okay. All right, there you go. One for you. The other one. Oh, look at that melty chocolate on there. Huh. Squish down the marshmallow.
Oh,
Little toast.
Yeah.
Tink.
Cheers.
To all of you remote students,
Oh.
sorry you didn't get to make a solar oven.
It's good. Tastes like summer.
The chocolate is definitely melted.
For sure. It's everywhere. It's everywhere.
Success! So here are some final thoughts on our solar oven project that actually relate to resistance in thermal systems. So we had our little bar of chocolate, and the bar of chocolate is solid chocolate. There's no air inside a Hershey's chocolate bar, it's just solid chocolate. And you can probably already see that just holding this thing, the chocolate is melting on my fingers. So chocolate melts at right around human body temperature, about 98.6 degrees Fahrenheit. So it does melt in your hands. And the whole point of the M&M commercial, or M&Ms, is they put a candy coating on the outside so it melts in your mouth, not in your hands. Normal chocolate's going to melt in your fingers. Delicious. And I still have chocolate on my hands. The marshmallow, on the other hand, is a little different. Even though it has the same melting point as the chocolate, marshmallows are puffed up full of air. And air is a great insulator. Air has a huge amount of thermal resistance. And that's why when you put fiberglass insulation in an attic or a roof, there's a rule called fluff it, don't stuff it. When you put that fiberglass insulation in, if you buy a 6-inch wide roll of insulation and it's 6 inches wide, you don't want to cram that into a space that's smaller than 6 inches. You want to put it in a 6-inch space so that it fluffs out. Because what the fiberglass insulation does is it traps air inside the fibers and around the fibers. And that trapped air is actually what provides the resistance, and it prevents the heat from escaping out through the roof of your home. So again, that rule for fiberglass fiberglass insulation is fluff it, don't stuff it. Don't allow the fiberglass to be compressed, because it's not the fiberglass that's doing the insulating, it's the air trapped in around the fiberglass that's doing the insulating. Well, the same thing's true about a marshmallow. A marshmallow is filled with air. So when we had this in the solar oven out there, the heat would heat up the exterior of the marshmallow, but because there's air, little pockets of air within the puffed up marshmallow, the air inside there would not allow that heat to penetrate deep within the marshmallow. The marshmallow, in fact, insulates itself. It has high thermal resistance. So it makes sense that the marshmallow did not melt. The marshmallow had a difficult time. Even though we got this to the melting temperature of marshmallow, the air inside prevented that heat from getting deep within the marshmallow, and that kept the marshmallow from melting. And well, I've already got some chocolate on my marshmallow from the chocolate melting on my fingers, so bon appetit. And remember, it's all about thermal resistance.